Hey guys, how's everything going? This is JSer, who is not good at algorithms. I'm making these videos to prepare my interview next month. In this video, I'm going to take a look at 5 to 3 continuous subarray sum. We're given a list of non-negative. It might be 0. Numbers and a target integer. Okay, it might be minus. Write a function to check if the array has a continuous subarray of size at least 2 that sums up to a multiple of k. That is, sums up to n by k, where n is also an integer. It might be 0, it might be minus. So let's something like this. We're given to search for target 6, because 2, 4 sums up to 6. Okay, for this array, all of them sums up to 42. It's 6 by 7, so it's also, we need to return true. Well, the first idea is come to our mind is to do multiple, why do I say multiple? Brute force, right? So how many subarrays are there? If we pick a start index and end index, there will be n square, right? And then we need to calculate the sum, right? So there will be times n. So it's n cubic. Space, there is nothing space, nothing used, so it's constant. So obviously cubic is not good. We need to improve, right? One thing is that if we freeze a start index like 23, when we are choosing, we can fix this start index and choose all the possible end index, right? 2, 4, 6, 7, and for that, actually, for the sum, we can cache the sum of a previous calculation. Like we cache the sum of 23 plus 2, and then we can just plus once to get the sum at 4, right? Plus 1 to 6, and plus at 7. So actually, we could improve to n square, right? Without the final this extra n. We're getting the index of any index, and we're getting the sum at the same time. So this might be good. Let's first try to improve this one, okay? Yeah, so the idea is very simple. We first choose the start index, which will start from 0 to nums, because at least 2, right? We start and end here. Sum is equal 0. If sum divided by k might be 0, remember. So we need to, if k equals 0, and sum equals 0, we return true. For the, oh no, we will check. If sum equals 0, we return true. For when k is not 0, if modded equals 0, we return true, right? So actually the problem becomes, we can just, if k, we could set it to 0, we could get mod, right? If mod equals k 0, then it's sum itself. If not, it's this, right? And then we say if mod equals 0, we return true. We can remove all of this, and then finally return false. So this should work. Yeah, let's submit. What's wrong? sum mod k. If mod equals 0, then it's true. So for 0, we start with 1, 1, right? It's not, and then 1. I'm stupid. It should be nums I. Cool, we're accepted. And could we improve this? Let's try to improve it. Okay. I remember once that we're doing a related question. It's about getting the sum array something from array. The idea is that if we want to calculate the sum of a subarray, rather than we sum them up one by one, the other case is that we can cache the result like sum this, and then just to do the subtraction, right? If we're going to sum here, the sum here equals the sum of this array minus the sum of this array, right? So that gives us the hint if we can improve by that. And at the same time, we're gonna check the if the sum equals to the multiple of k. Let's analyze the input like this. Actually, for the sum, we could just mod the k, right? It doesn't change the result. Like we're giving the, if we divide it by 6 beforehand, it actually is the same as the input of 5, 2, 4, 0, 1, right? Remember the subtraction we mentioned? If we calculate the sum of like 2, 4 of the sum is the multiple of k, then if we mod it by k, it must be 0, right? So the sum of here, the mod sum of this subarray must be 0. So it reminds us that if we accumulate the sum, then there must be a subtraction that equals to 0, right? Let's try to sum them up. This is the mod array. Then the sum from 0 from the start to here will be 5, and here will be 7, right? 7 mod 6 is this 1, right? And then here it's 5 again. We see we made a 5. It means the numbers here actually sums to the multiple of k, right? Because these mods are the same. Well, this is the idea. Let's try to do it. So we're getting the mod array, right? And to check if it exists or not. To check the existence, we could use search, but we could use a map to do it more quickly, right? And we need to check it at least 2, so we need to also store the index. So it's a map const mods new map. It's map mod index. Okay. Now let's start. Let sum equals 0. Cool. Now, of course, first we sum the nums, right? Sum the number, and then we check if the sum is already in the mods map, right? If it is, we check the index. If it's 2 if it is 2, if it's to what? If it's 2, 1, 2. So if it's the index is 2 before, 2 slot before, then it is valid. Okay, so let's see if mod. Oh, the sum, it might be over then it might be over k. We need to check it, right? If it is 0, we do nothing, right? If it is not 0, we mod it by k. And then if mod has the sum and what if, should we update the index? No, we should not update the index. So if there is the same, but in instance is just 1 before, then like this 4 and this is 1 is 0, then they have the same mod. Should update index say here? No, because we're getting at least 2. So the farther the better. So if it has it, if it doesn't have it, set it. If it is not in the map, we will update it, right? Set sum I. If it is in the map, we check the index. If mods get sum smaller than I minus 1, then we return true. And the for loop is done. We return false, right? Let's try to run the code. Yay! The wrong answer. The input is 000, 0, because for 0, the sum is 0. The k is 0, so we do nothing. Mod, well, 0, 0, it has both has a sum 0, but index is only 1 slot up before, so we didn't return true. Well, but obviously this is the true case. Should we do it? If we suppose that there's a false head at the beginning, it will make things better, right? If we add a false 0, and for k is not 0, the 0 would not harm, right? Why? Let's suppose that there is a subarray sum to a specific k which is not 0. Then if there is a if the 0 is in the middle, it should be included. But if it is the head, it should be avoided, right? It will not be counted, because the sum array like this only change when the number is not 0. So even if we added 0, it doesn't matter. Or there's another way we check this. We can say there's a special case of all 0. So if sum is 0 and if sum is 0, if sum is 0, like if it's 6, then sum is over. The sum is 0, right? Sum is 0, and then so the sum would not. If sum equals 0 and the k is not 0, and there must be, it must be 2 zeros, or it sum up, or it sum up to that number, right? Yeah, 2 4. The sum would be 2 0, right? Okay, this is a valid case actually. So if this is the first, I see. If the first two, like first several numbers sum up to the multiple of k, then there will be actually 0, the first 0 occur. So actually, if we say mods get sum smaller than I minus 1, we could just add a false 0 here, right? Yeah, say mod set 0 minus 1. Suppose there's a 0 at the beginning. It will handle this case very well. And if not the case like this, it's like 2 4, 2 3, and then 1 5. You see that it will be 5 0 and 5. So it still doesn't matter, right? So we add a 0 here. Let's try to submit. Modes is not defined. Oh, mods. Cool. We are accepted. And or I think if for the rather than we set a false head, we could check if this is the first 0 and this index is bigger, and this index is bigger than 1. If the first one is 0, then actually if we forgot about the length, the sum must to 0 actually will be a valid result. The only invalid one will be only 1 0, right? So if mod has sum or sum equals 0 and I is bigger than 0, this will also, I think this will also work. No? Really? So the sum 0, okay, and I is bigger than 0, right? No, my bad. I add a special case here. If this, return true. This should also satisfy our needs. Yeah, this is the same. Cool. Special case of excluding. Okay, if sum is 0, then all are 0. Only in valid cases 1 0. So we filter this one case out. Let's try to analyze the time and space complexity. For time, we're using one for loop, and yeah, that's it. So very good. It's a linear time. Space, we use a map to store the sum, right? Actually, worst case is on k equals 0 and the last two numbers being 0, right? For that case, we need to store all the sums. So the worst case is, yeah, linear for all. But generally, if k is not 0, it should be nk minus 1 if k is not 0, right? Because we mod it. Cool, that's all for this problem. Hope it helps. See you next time. Bye bye.